It is my immense pleasure to present this topic for first semester students of our college, Kadir Moidin College, Adarampattinam. This topic is a very simple topic. This topic is present in Physical Chemistry 1 paper for MSc students of our university. This slide shows the syllabus related with this topic.
This slide shows a request to viewers.
Laser means it is an acronym of light amplification by stimulated emission of radiation. Consider an isolated atom in the excited state. It can return to ground state by spontaneous emission of photon with the frequency nu. Now the excited atom, if the excited atom is struck by an outside photon precisely having same frequency that would be given out by the atom in spontaneous emission, then two photons are emitted. One photon is used for striking the excited state atom. Another one is the photon emitted by excited state atom. So now these two photons are having the same characteristics. That is, the incoming photon reinforced by one given out by the excited atom. So such a collection of large number of photons, that is called laser beam.
This slide shows absorption of photon and excitation, that is excitation process. And another second one is spontaneous emission. This slide shows absorption and spontaneous emission. Now this slide shows stimulated emission. Stimulated emission means one photon is emitted by excited state atom. Another one is the photon used to strike the excited state atom. Now the two photons are emitted. Both are having same characteristics. So the two photons are in phase. Now the remarkable features of stimulated emission laser beam are: 1. The emitted photon is in phase with the incident photon. In phase. The emitted photon is in phase with the incident photon. Another one is it has same polarization of the incident photon. And third one, it propagates in the same direction as the stimulating wave. So such type of stimulation of large number of emission of photons, that is called laser beam. Here the figure shows spontaneous emission, that is absorption followed by emission. Another one is stimulated emission, that is the excited state atom is stimulated by another photon with the same frequency. Then the emitted photon, two photons are emitted with the same frequency, same phase, same polarization and same direction. Such type of collection of large number of photons, that is called laser beam. This slide shows emission from incandescent lamp and from laser. So in the first figure, the emission of photons, the photons have many wavelengths, multi-directional, incoherent. That is emission of photons from lamp, incandescent lamp. But in the from laser light, the beam emitted, that is the radiation emitted, is monochromatic, directional and coherent. Such type of emission is called as, such type of rays, that is called laser beam. The primary condition of laser action is to create population inversion between energy levels. Now this cannot be achieved if there are two energy levels. But to achieve population inversion between, it is necessary to have a system with three energy levels: E1, E2, E3. All these are shown in this slide. And E1 energy is less than E2 and E2 level has energy less than E3. Now we have three levels, one E1, E2, E3. Now the photon is excited to from E1 to E3, E1 to E3. That is called pump radiation. Afterwards, it follows intersystem crossing and it becomes in the state E2, and a population inversion is created. Afterwards, it emits radiation, and that is nu 1 2, that is called laser beam, and the fluorescence emission, that is given by uh, number 3. So that is fluorescence emission, but laser beam is a frequency, that is nu 1 2, frequency. So nu 13 is the pump radiation, and that is first process. And the second process, that is intersystem crossing process. Afterwards, the fourth one is emission of laser beam. So E2 is necessary for a system of population inversion. Thus, a laser system consists of 1. A system with a set of energy levels of suitable magnitude. 2. A pumping system to excite the system for population inversion. And third one is optical cavity. Now, this slide shows emission of laser radiation. Now we have three levels. One level, ground state E1, and the excited state, that is E3. And first the ground state molecules are excited to E3 state, and the molecules becomes in metastable state, which is E2 state. Afterwards, the molecules are stimulated by stimulating emission, and laser beam is generated. Laser beam is generated. So this slide shows all these steps, that is pumping radiation, and then intersystem crossing from E2 to E3 to E2.
So far, we have discussed the principle behind the generation of laser beam and characteristics of laser beam. Next, we have to see applications of laser beam. There are a number of applications for laser beam. One application is laser in Raman spectroscopy. The principal experimental difficulty of Raman spectroscopy before 1964 was measurement of weak scattered radiation. However, the use of lasers as the exciting source has greatly enhanced the use of Raman spectroscopy in all branches of chemistry. That is, on using laser beam, um, the spectroscopy, Raman spectroscopy, is applied in all branches of chemistry.
This slide shows a typical Raman system using laser radiation. So laser radiation is very much useful in Raman spectroscopy. Next application of laser radiation is biphoton process. So it is the theoretical interest. So electronic transition occur when an atom or a molecule absorb a photon of radiation between ground state and exit state. This is a one photon process. But using laser, it may undergo two photon process. That is, the system goes to the exit state with the absorption of two photons. For a two photon transition, ground state and exit state must have same symmetry. That is, two photon transitions are considerable theoretical interest in spectroscopy. So these are about the theoretical interest about the biphoton process in using laser beam. The ground state and exit state have the same symmetry due to absorption of two photons. So that is a theoretical field.
This slide shows one photon process and two photon process. In one photon process, one photon is absorbed. In two photon process, two photons are absorbed.
Another application of laser beam is study of the nature of bond. With a sufficient intense laser, one can study the nature of chemical bond, and it is possible to break a specific bond in the molecule. So that is another application of laser. And fourth one is to detect small number of atoms. Using laser, it is possible to detect small number of atoms produced by interaction of low energy solar neutrons. So there are a number of applications of laser. So here four applications are discussed. So sometimes question may be asked, what are the applications of laser beam? Now we can answer the four applications.
With this, I want to conclude my lecture on laser and its applications. This topic is very simple topic. Questions are frequently asked in the university examination. I wish all the students are success. I expect comments from the viewers in the comment box. I express my sincere thanks to all viewers. Thank you, one and all.